Alright, so now that we have link local IPv6 addressing and we have IPv6 routing enabled on the router, and all these devices have link local addresses and the router has a link local address for each of its interfaces, we need to set up some global unicast addresses that are routable so that we can communicate from one network, or this subnet right here, to this other subnet right here. And to do this, we're going to have to create two IPv6 networks with separate addresses for each subnet. In the Cisco Academy, we use a global unicast address for these purposes that we can subnet, and this address is let's say, is in the range of routable IPv6 addresses, but it's been set aside for demonstration and for teaching purposes. So this address starts like this, 2001:DB8, and this is basically the Internet Registry part of the address. This is the Internet Registry prefix. And then let's say this is our ISP will give us our own prefix to identify, let's say, our company. And in the Academy, oftentimes it's used like this, ACAD, right? Or something like that. But in this case, we could just say like AAA, right? So 2001:DB8 AAA, which defines, let's say, the prefix for our company. And then in the next portion, we can put our subnet. So in this portion, we can put, let's say, 000A, and so this will be subnet A, let's say, and then I'll put : 1, and the 1 signifies that this is the first address or the first host in this subnet. So basically, if we were to write out this address in full 128-bit form, it would look something like this. So I'll put it down here just to give an example. All right, and this will be long form. So we would have a 0 here, actually, and then we'd have 1, 2, 3, 4, and then : 1, 2, 3, 4, and : 1, 2, 3, 4, and then 3 more zeros, and this would be the full address. And this is a 128-bit address, and if you divide it in half, you have 64 bits on either side. So the first 64 bits right here, and you can see this is in hexadecimal numbering, so it's actually 4 hextets. You can see 4 hex characters, 4 hex characters, 4 hex characters, and 4 hex characters, or 4 hextets. Now, we have this identifies the network prefix. This is essentially the network portion of the IPv6 address. You have the registry prefix here, and then you have the site prefix that's been assigned to you, let's say, by your ISP, and then you have the portion that you can create your subnets with. And all of this makes up the network portion. Now, the end portion, the last 64 bits, or 4 hextets, identify the interface ID, or you could call it also the host portion. This would be the host, identifying the host. In this case, it's called the interface ID, but it identifies the host on the network. And in this case, you can see we've got all zeros and then a 1, so this is the first host on the network. So this would be an appropriate address to give to the router interface, let's say, possibly. So we could put that right here. And when we condense this address or compress the address, we can get rid of the leading zeros. So we can get rid of all of the leading zeros. And then all of these remaining zeros can be expressed with just 2 colons. So I can delete all of those and just put in 2 colons. And then this is the address in compressed form. This is subnet A, and it's the first host in the address. All of the zeros have been omitted, and we're just left with : 1. Now I'll select this, copy it, and paste it, and this will work also for the other network, except all I have to do is change the subnet to, let's say, the B subnet, or any other number that I want to use. So subnet A subnet B, the first host address, the first address identifying the interface will go to the router, and all we need to do now is configure the router with this addressing. And one other thing before I forget, when we go to configure these global unicast addresses on the router, we're also going to need to include the slash for the network prefix. So in the address, it's the address and then /64, and the /64 identifies that the first 64 bits from left to right in the IPv6 address are for the network portion. So I'm going to put that in right here, /64, to let us know how long the network prefix is. In this case, it's 64 bits long to identify, or this long to identify the network prefix. And now we're ready to configure the router. So we'll go in the router, and we'll hit return to get started. Stretch this out again. Type enable. Conf T to get to global configuration mode. Interface G0/0 to get to gigabit 0/0. IPv6 address, and then I'll put it in 2001:db8 :AAA:1/64. All right, and that looks correct. If I can just double check that. Yes, that looks right. All right, I'll hit enter. And we have our address in there now. I'll put no shut again, although I don't need to do that. And then I'll go to the other interface, up arrow, and change that to a 1. Now I'm in interface gigabit 0/1. I'll up arrow again and just switch this over. Use the arrows on my keyboard and change that to a B. And now the second interface is configured. So now we've got global unicast addresses on each interface, right? I'll go over here to PC1, go to IP configuration, and to configure the global unicast address on the PC, we can use auto configuration or Slack stateless address auto configuration, and it will automatically contact the router, figure out what the subnet is, and then auto configure its own address and receive the gateway address from the router. So I'll just select auto configuration, and you can see, sure enough, it figured out that this subnet is the B subnet. It put in its Slack, basically, which is a combination of the MAC address. You can see the FFFE inserted here, and it basically auto configured its own global unicast address by contacting the router and figuring out what the network prefix was. It also figured out that the IPv6 gateway, that the gateway is FE80::1. It got that also from the router. So that's awesome. So I'll just do that, and I'll get PC2 and do auto configuration here. All right, wonderful. And then on PC0, the same thing. Auto config. Let's see if it figures out. Yep, look, there's the A subnet. So PC0 is on the other network, and it auto configures. And all we need to do now is see if we can ping across the network. So to ping across the network, I can't seem to select this right here very easily. So what I'll do is I'll grab the link local address. I'll copy that. Okay, so I have the link local address copied from PC0. Now in PC1, I'll go to the command prompt and I'll say ping. I'll put in the link local address, but then I'll change it to be the global unicast address. So 2001:db8:AAAA, right? :A, and then there is the IPv6 address. And now all we need to do is hit enter, and you can see that we're getting replies. So we were able to ping across from PC1, from this subnet, from this network, ping across the router to reach PC0 on the other subnet. Now, we did not have to add any static routes or any dynamic routing protocols to the router, because it's only the router that we're going through. In other words, the router has one network on one interface and another network on the other interface, so the router knows about the two networks, and so we didn't have to configure any static routes or anything like that. We just needed to ping, and it works. So that is good news. We can also, let's just type it in, ping 2001 colon DB8 colon AAAA colon B colon 1, and we can ping our gateway. So PC1 is also able to ping itself, let's say, or not ping itself, but ping its gateway on its subnet. So that's pretty nice. Now, one thing I will warn you of, if your ping does not work, you need to make sure that when you select the PC, that the IPv6 gateway is still there. Sometimes I've found that with the auto config, it will lose the gateway address. The IPv6 gateway address will sometimes not be there, and so then I'll have to go to static and then go back to auto config to make sure that that's still there. So you have to, if it doesn't work, check to make sure that, don't get frustrated, just double check to make sure that, see, you can see here it's disappeared, right? The gateway is lost. So just make sure that it's still there. Maybe don't even close the window here, just set it aside or minimize it, and then try your ping again, and it should work, right? You can see it should work. And if it doesn't, once again, double check to make sure that the auto configuration worked. All right, so that's IPv6. We're able to configure the entire thing with IPv6 addressing on all of our clients and on the router, and we were able to communicate from one network to another. Before I close out the video, let's take a quick peek at the configuration file inside of the router. So I'll hit enter, enable, and then do a show run, and we'll take a look at the configuration file. You can see up here in the running configuration, there is the host name, there's the IPv6 unicast routing command that we put in, and then here's our interfaces. You can see here there's no IPv4 address on these interfaces right now. It's just IPv6, and we've got our link local address, and we have our global unicast address, and we have both of those also on the other interface as well, and that was enabling the communication to work.